ఏ టాపిక్ చెప్తున్నానా? విచ్ టాపిక్ we are discussing?
Sir, off-bow principles in electronic configuration.
Acha, we have discussed or
We discussed, sir.
acha. So Abbo principle and the diagram also I had given, right?
It's the order.
Given or not? Okay. ಅದು ಇದೆ ಬಾಬು. ఓకే స్టూడెంట్స్, సో నెక్స్ట్ టాపిక్ వచ్చేసరికి హండ్స్ రూల్ అండ్ నెక్స్ట్ పాయింట్. కెన్ యూ సీ మై స్క్రీన్?
Yes, sir.
నెక్స్ట్ ఈజ్ హండ్స్ రూల్. Hunds rule, what it says, Nana, generally, it is applicable for applicable for
It is the box one, right?
which one, Nana?
The Hunts rule is the box one, right? Like we draw arrows, that one.
Yes.
Okay,
Okay.
sir.
Next, what we can say, in degenerate orbitals, pairing of electrons takes place after filling each orbital by one electron. Each orbital by one electron. Okay, in degenerate orbitals, the pairing of electron takes place after filling each orbital by one electron. We can say this is what we can say about the Hunds rule. Okay, na? So in this one, what we can say that, see, for example, if I'm taking p orbitals, in p orbital there are three degenerate orbitals are there, right? This is what we can say px, py, pz. So what I'm trying to say, so in this one, what we can say, so first we need to fill one electron each in each orbital like this. Okay, then we need to start pairing. That means in p orbitals, the pairing of electrons takes place from fourth electron, and similarly in d orbital from sixth electron, and in f orbital
Yeah, I think 10th electron.
Eighth electron, no?
Eight, sir,
Okay, sir.
because seven are there.
Yes, very good. For example, if I'm taking
Sir,
P4 P4 configuration, if I'm writing,
Sir, can
okay,
you go to the
writing,
previous?
hello,
Yes, sir.
sir, what are degenerative orbitals?
degenerate orbitals means orbitals having, okay, same energy.
Sir, can you go to the previously advanced?
Sir, we can add as many electrons as we want in each orbital, sir.
In each orbital, we can, how many electrons we can say?
Sir,
In p orbitals,
some
no,
orbital means
in
3,
p
5,
orbitals,
7.
no, no, in p orbitals, how many electrons we can fill?
Is it 6, sir?
Six it is, right? In six orbitals, so there we can fill from each orbitals two electrons we can fill, no?
Sir, so in that orbital, more than 6, we can't even fill, sir.
Yes.
Okay, sir.
Okay. Hmm. Okay, students. Hello.
Yes, sir.
Yes, sir.
Hmm. Now see, in P4, what we can say here. For example, if I'm writing like this, can we write like this?
No, sir.
Why?
Sir,
Because
First, because
4
we
means
should fail
four
only
electrons,
electrons
sir.
and then we do pairing, sir.
yeah, okay. So here it is according to Hunds rule. This one is wrong and it is correct. Okay, na?
So P4 means 4 electrons, sir.
Yes, four electrons in p
Okay.
orbitals. Okay. Hmm. This is what we can say about the P4 configuration. And next one,
Sir, I didn't
uh,
understand, sir.
okay, in degenerate orbitals we are saying, right? For example, if I'm taking, uh, in case if I'm taking D3, if I'm writing, we know that is 3 electrons in d orbitals, right?
Sir, yeah,
So in that one,
sir.
what we can say, there are two possibilities we can write. Those who understood, no, please be quiet, Nana. That is, we can fill 3 electrons like this. We can fill 3 electrons like this. And second thing is, uh, or we can place like this. Which one is correct? Because first one is correct as per Hunds rule, right? Because here say in this one what we did here we have paired the electrons. But what is Hunds rule says, you need to pair the electrons. First you need to fill all the electrons by at least one orbit, one electron. Okay, you need to fill all the orbitals by one electron each, and after that only you need to start pairing. Now see here there is a vacancy is there, but still we are pairing. That means this is goes against to Hunds rule.
What
Against
is a pairing, sir?
pairing means in orbital we can place two electrons, no, na?
Yes,
I
sir.
told you, no, in P we can have 6 orbitals we
A
can fill.
suborbital.
So in that one, two electrons from each orbital,
Yes,
and the
sir.
two electrons also how it will spin. We should discuss in spin quantum number. If two electrons are there in a orbital, so it can revolve in two directions. One is
Yes,
clockwise
sir.
direction, one is anti-clockwise
Anti-clockwise.
direction. First it will spin its own axis, and after that it will revolve, okay, around the sun. Just how planets, how Earth revolves, no?
Yes, sir.
In the same way it will there.
Means if the arrows are one is down and one is up, we should not do it, sir.
Yes, that means upward arrow indicates clockwise and downward arrow indicates
Anti-clockwise.
anti-clockwise. That's it. Okay, na? Hello.
Yes, sir.
Is it
Yes.
clear?
Yes, sir.
Mm. Next one. Next one what? Next one చూడమ్మా. This is answer. Next one what we can say? Police exclusion principle. Okay, police exclusion principle. What is police exclusion principle?
Sir, this is the second one, sir. Okay.
Third rule, no, Nana. So policy exclusion principle says that, okay, na? According to this theory, no two electrons, okay, no two electrons will have all four quantum numbers equally. Okay. So what is that no two electrons will have all four quantum numbers equally? That we need to discuss right now. Okay. So according to this theory, no two electrons will have all four quantum numbers equally. Okay, according to this theory, no two electrons will have all four quantum numbers equally. It will be there. Okay, na? So what is this theory says? So what is this? No two electrons in a no two electrons will have all quantum numbers equally in an orbital. So what are the quantum numbers we have? We have four quantum numbers, right?
Azimuthal, magnetic quantum number, principal quantum number, spin quantum number.
Spin quantum number, right? Now, for example, let me take okay, I'm writing 2s2 electronic configuration if I'm writing. That means what? There are two electrons in s orbital. That s orbital belong to second cell. Okay, na? So if I'm taking a box method, what we can write? We can write like this. Okay. So let me write. Okay, let me write in this.
Sir, the left side of the arrow is L.
L.
Here, sir, in the box.
Array, nana, it is arrow, nana. Arrows, two electrons. Okay, so this is 2s2 configuration, right? And 2s2 what we can write? We can write like this, isn't it? Let me take this is electron A. A electron I'm indicating like this, okay, na? There are two electrons, no? Just I'm giving two names. And this is B electron. Otherwise, you can take it as first electron. And it is, second electron. Okay, na? Now in first electron, what is the n value? What is the n value? Tell me. This electron in which cell it is there, Nana?
Second, sir.
Second cell. So n value will be 2. And what is L value? What is L value? Tell me. You need to respond now.
Sir, is it 4, sir? Sorry, 5, sir.
5 how, Nana?
Sir, 0.
0, na? Why? Because it is s orbital, na? For s orbital, what is L value? 0, na?
Yes.
And what is M value?
5. Sir,
If L
0.
equal to 0, what is M value? M value also be 0. And S value will be how much? It will be plus of.
Yes.
Okay. And for second electron, what is N value here? We can write 2. And what is L value here? It is same as it is there in S orbital, it can be 0. And M value also, if L equal to 0, M value also be 0. And S value will be how much? It will be minus of. Now see, if 2 electrons I am taking, for that one, N value same, L value same, M value same. But where we got difference? Where we got difference? In M value. And if I am taking one more electron of 3p2 configuration, if I am taking. So P means how we can write? We will write like this, no? This is one electron, this is one as per Hunds rule. So let me take this is px orbital and this is py orbital and this is pz orbital. Okay. So for this electron, let me take that is first electron. I am taking this electron as first electron. And this electron I am taking as second electron.
Sir.
In first electron, what is n value? Where it is there?
Sir, 3.
3. L value?
So 1.
1. And M value?
So 1.
1. We can write now for px orbital what we can write? +1 or -1 we can write now. And S value will be plus of. If you forgot previous topics, how it will be? For second electron also N value will remain 3. L value is 1. And M value will be, it is in pz orbital, so that +1 it will be there. And S orbital will have plus of N again. Okay.
Sir.
Now say in this one where we can observe difference.
Sir, how can we determine +1/2 or -1/2, sir?
I told you, no, if whether two electrons are there, it will be clockwise, it will be if it is there plus of anti-clockwise. So I had written here clockwise I have taken. Okay, you can take minus of also, no objection.
Okay,
Okay,
sir.
na?
Yes, sir.
So generally we will take clockwise, no, that's why we have taken, I have taken +1.
Sir, and by the way, you wrote PX, PZ, and PZ, sir. 2 times you wrote PZ.
Where? Px, Py,
Yes.
just for pz orbital it is 0, right?
Yes, sir.
That means what we can say, where we are get difference, that means if two electrons are there, we can have difference either in s orbital or in, sorry, either in s values or in m values we can
Sir,
write.
L value only depends on the electrons, right, sir?
Which
L.
one, Anna? L depends
Yes,
on
sir. And
cells, no?
depends on
L
principal
value depends
quantum
on
number.
n.
Sir, M
Hello?
depends on a principal quantum number, no, sir?
M depends on L. L depends on n.
Okay, sir.
Okay?
Sir, I have a doubt.
Tell me.
Sir, in the 3p2, sir, why is M changed, sir? I did not understand.
Are you there in previous classes?
Yes,
Sasank, I think
yes,
the person asking.
yes, sir.
Are you there in previous classes?
Yes, sir.
Do you know magnetic quantum numbers we have defined from the magnetic quantum numbers only? We can define p orbital having three suborbitals.
Yes, sir.
In that one, we can have if L equal to 1, the p value, ml values will be -1, 0, +1. For pz orbital, conveniently we will take 0, whereas px is +1, py is -1.
Yes, sir.
That only we have written here. Okay?
Sir, that means we can change it, sir.
Yes, yes, you can interchange, no issue.
So what is the
Okay, so
formula
this
of
is about
how
the
to find L, sir, with the help of n minus 1 or n minus 2
which one?
to find the L value, sir? L.
L is what? For any L value, same number of for any n value, same number of L values will exist, no?
No,
And L
sir.
equal to what? N minus 1, it is not n minus 2. And as in this case, we are saying that the electrons are p orbitals, and fixedly we know, no? For p orbital, L equal to 1.
Sir, if n is equals to 2, then n minus 1 is equals to 1, sir.
Hmm.
So then why we got L is equals to 0, sir, in the first case?
S value, how much it is?
Plus 1 by
S value, S orbital, what is L value? For we have fixed, no? For S orbital, L equal to 0 for S orbital. We have discussed earlier case only, no? Yeah.
okay.
Okay. Next one is electronic configuration of elements. Electronic configuration of first 30 elements. Okay, what are the first 30 elements, Nana?
So
Hydrogen,
helium, lithium.
1s1 we will write. Okay, I have told you know the sequence.
Yes,
And
sir.
helium, what we can
Sir,
write? There are 2 electrons are there, so we can write as 1s2. And lithium, what is the configuration we can write?
sir, 1s1, 2s. So
One
1s to
Sir,
2s.
once can you കൊടുക്കത്തില്ല?
1s2, 2s1. Okay, here the 1s2 configuration is nothing but what? Helium, no?
Yes, sir. Sir, helium core, 2s1.
So here we can write what we can write? Helium core 2s1. Okay, now hydrohelium, lithium, next one beryllium. Beryllium 4 no
Helium
atomic
core,
number.
2s2.
First, what we will write? 1s2, then 2s2, which we can write as helium electrons already there. No? 1s2 can be written as helium. No? So helium core
2s.
2s2. Beryllium next to boron. Boron atomic number is 5. So configuration will be 1s2, 2s2, 2p1. Why we are not writing 1s2, 2s3?
So because in S orbital only 2 can maximum number of electrons is 2.
So in we have discussed no in S maximum number of electrons can be filled is 2, whereas in P can be 6, in D it can be 10, right? So this also how we can write helium core 2s2, 2p1, isn't it? Next carbon configuration is 1s2, 2s2, 2p2. That is helium core 2s2, 2p2. Are you getting how I am writing?
Sir?
No.
Okay, sir. I understand.
Okay. Next one. After carbon, what we are going to get?
Nitrogen.
Nitrogen. Carbon, nitrogen. Nitrogen atomic number 7. No? So what is the configuration we can write? 1s2
2s2, 2p3.
3.
So 2p.
2p3 only, no?
Yes, sir.
This we can write helium core 2s2 2p3. Next to oxygen. So we can write as 1s2 2s2 2p4.
2p4.
That is helium core next to fluorine. Fluorine configuration is 1s2 2p5. So again we can write it as a helium core 2s2 2p5. Next to neon. Neon atomic number is 10, so that we can write as 1s2 2s2 2p6.
2p6.
And neon after sodium we can write now. Sodium is 11, so that we can write 1s2 2s2 2p6. After 2p what we can write? 3s1. Now see here. Neon is 1s2 2s2 2p6, right?
Yes, sir.
So this is what we can write here. Up to this we can write neon, no? Neon core 3s1. Magnesium atomic number. Tell me configuration, students.
So 1s2,
Sir,
Next to
1s2,
2s2
2s2, 6.
Sir,
2p6
neon.
6, 3
So 3s2.
s2.
Sir,
Ne-
neon core.
Sir, neon
Neon core
3s2.
3s2.
Good. Okay. Next,
Sir, one can go to the previous slide.
make it fast, Nana.
Yes, sir.
Okay.
Yes, sir. Sir, done.
Then after magnesium, what we are going to get?
Aluminium.
Aluminum. So you can write like this, right? Can you write like this? Can you continue like this?
Yes, sir.
Now, just I'm randomly I'm taking chromium atomic number 24. Tell me the configuration.
Sir, 1s2,
1s2,
2s2,
2s2,
p6.
2p6,
1s2 2p6 3s1
Sir, 3s2, 3s6.
3s2,
So 3p6.
3p6,
3d10
4s2,
4s2.
3d10
3d4.
Done.
Yes, sir.
As per our method, it's supposed to be like this, right?
Yes, sir.
Okay, na? But actual configuration will be this is actually wrong electron configuration. But actual configuration is it will be like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Sorry, we can write as 4s1, 3d, 5.
5
So what is instead of d4 we are writing here d5 we are writing. Okay, na? In the same way,
Why, sir?
let me finish, no, yeah. One more, if I'm taking copper atomic number is 29. The configuration will be what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9 we will write. This is actually wrong again. The actual configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3D 9. So if you are observing in 4s2 3D 9, instead of 4s2 3D 9, we are writing as 4s1 3D 10 we are writing. So why we are writing like this? Okay, what is the reason? Okay, this is known as a exceptional electronic configuration we can say. Okay, we can say exceptional electronic configuration we can say. So what is the reason for exceptional electronic configuration? Okay. Exceptional electronic configuration. This is actually we are writing, normally we should write like this, but we are writing this. Okay, na? So that's the reason what we can write. What is the reason for exceptional electronic electronic configuration? Okay, and the reasons. Actually, the reason for exceptional is completely filled or half filled d orbitals or f orbitals, completely filled, completely filled or half filled d orbitals. Not only d, you can write completely filled or half filled orbitals. You can write completely filled or half filled orbitals are more stable. See here d5 means what we can say, what we are writing d5 means, likewise we can write now. And d10 means how we will write? Huh? Example what we have taken, example is d5 and d10. Take a more stable regions, what we can say, there are two regions are there for this. Okay, there are regions. First one what? Symmetry. Okay, now say if I'm taking d5 electrons as per Hunds rule, how we will write, Nana? Tell me. As per Hunds rule, how we will write? We will write like this, right? And now see, all electrons are having same direction now. Either we can fill like this or we can fill like this. That means all electrons either clockwise direction or anti-clockwise direction. So because of symmetrical arrangement of electrons, and d10 how we will write, we are having only one possibility only in case of d10. This is about d5 and this I am writing as d10. So there is only one possibility, we can write like this. So in this one what we can say, either we are having maximum spin or minimum spin if I'm taking. Okay, that means what we can say, greater the symmetry of electron, greater the stability. Okay, what we can write? Greater the symmetry of electrons and greater the stability we can write. Okay, now students. Hello.
Yes, sir.
Okay, and
Yes,
next one
sir.
what we can say? Second reason is exchange energy. So exchange energy అంటే ఏం చెప్పుకో జనరలే. So how an orbital, for example, let me take. I'm taking for d5 nana. Just you calculate. Okay, na? Now if I'm taking this is first electron, second electron, third electron, fourth electron, fifth electron. Now if I'm taking a clockwise or anti-clockwise, any one direction if I'm following, no, what we can say, the first electron can exchange with position of second electron, or the first electron can exchange with position of third electron, or with fourth electron, or with fifth electron. So for first electron, how many exchanges are possible? 4 exchanges. For the second electron, it can exchange with 3, or it can exchange with 4, or it can exchange with 5. At the same time, a third electron can exchange with this or with this. Now a fifth electron can exchange with only this area only. So now total how many exchanges are there? Total how many exchanges are there, Nana?
10, sir.
10. So now according to this, what we can say, greater the okay, greater the hello.
Yes, sir.
Uh,
Yes, sir.
so what he is saying that generally greater the exchange energy, greater is the stability. Okay, greater the exchange energy, greater the stability. Okay, greater the exchange energy, greater is the stability. So by taking these two reasons only, half filled or completely filled orbitals will have always more stable. Okay, na students? Students, అర్థమైందమ్మా?
Yes, sir.
Yes, sir.
So this is only we are having. Okay, this is only we are having half filled or that chromium copper we are having exceptional electronic configuration. Now say in case of actual total 28 108 electrons, no, we are having different elements which can exceptional electronic configurations are there. But as of now we need only okay. As of now we need only these up to 30 elements only. Hello.
Yes, sir.
So up to 30 elements only we need to focus. Okay. సో ఇక్కడ మనకి అటామిక్ స్ట్రక్చర్ టాపిక్ అయింది నాన్న. మీకు చెప్పిన టాపిక్ లో అటామిక్ స్ట్రక్చర్ టాపిక్ అయింది. సో కంప్లీట్ టాపిక్ అటామిక్ స్ట్రక్చర్ అనేది అయిపోయింది ఇక్కడలో.
Sir, so next types of bonds, sir.
నెక్స్ట్ టైప్స్ ఆఫ్ బాండ్స్ చెప్దామా లేదంటే పీరియాడిక్ టేబుల్ చెప్దామా?
Sir, types of bonds, sir, because periodic properties, I think you explained to all again.
Chemical bonding.
ఓకేనా? సరే, పీరియాడిక్ టేబుల్ ఆల్రెడీ సమ్ ఆఫ్ యూ పీపుల్ ఆర్ హ్యావింగ్ ఐడియా, రైట్? So let's go with chemical bonding. We will discuss. Okay, na? One more important topic. That topic types of bonds we can discuss, and in next class onwards we can discuss types of bond. Okay.
Okay, sir. Thank you, sir. Bye.
Bye, students. Good night.